Hi everyone, it's Mr. Kwan. Today we're going to be talking about area. Area takes up space. Unlike a line or string to wrap around something to find the perimeter, we now are referencing all the space within the perimeter. You can think of area as how much material like bricks, tiles, carpet, or paint it would take to cover a given space. Can you think of some examples of area? If you are given a rectangular shape, do you know how you would find the area? Take a moment to think about these two questions. In the meantime, let us think of carpet tiles in this situation. So we have a photo here. It's a room that's carpeted, but it has like square tiles of carpet. So someone had to think about how many of these tiles in each color would be needed to cover the floor in this very cool pattern. Before we do anything too fancy, let us look at some ways to represent area mathematically and visually. Note, the drawings below are likely not drawn to scale unless they have a legend or are on graph paper. So let's go ahead and jump to example 1. We are given this rectangular shape, and we are asked to find the perimeter and the area of the model. So let's tackle the perimeter first. So the perimeter, it's a rectangular shape, so we know that the perimeter is equal to 2 times the length plus 2 times the width. And so first we have to figure out what the length is. So the length is this top measurement here. We know that the first portion is 20 and then the second portion is 5. So the total length from here to here will be 25, and there are no units on it. We don't know if it's feet or inches, so let's just leave it as 25. So we have 2 times 25 plus 2 times whatever the width is. Now, the width is the measurement from here to here, and we know that the first part is 10 and the second part is 3, so the total measurement is going to be 13 because we add 10 plus 3 together to get 13. So I'm going to put 13 in here inside my parentheses, and we're going to simplify that. I'm just going to throw that into my calculator. So we have 2 times 25 plus 2 times 13, and that is equal to 76 units. I'm just going to put units since we don't know if it's inches or centimeters or feet or anything like that. All right, so let's go ahead and erase this stuff. Now our goal is to find the area of this rectangle, and there are 2 ways that we can go about finding the area. So the first way is the area of a rectangle. Hopefully you've seen this formula before. If not, that's okay. The area of a rectangle is the length times the width. And so you'll often see that as just length times width, like that, L times W. So we already found L times W in the previous calculation when we were finding perimeter. And so let's remind ourselves the length was 25. And in fact, let me put 25 units. And the width was 13 units. And so when we multiply those together, we have 25 times 13, and that is equal to 325. But because we're also multiplying units times units, that is units squared. So that is our formula for area. But notice that our rectangle is comprised of 4 smaller rectangles. So we have one rectangle here, a second rectangle here, a third rectangle here, and a fourth rectangle here. Now, all area is the measurement of how much space is being taken up. And so there's actually a second way of calculating the area here. We can calculate the area of the 4 smaller rectangles and then add them all together. So I'm going to go ahead and calculate those. Since this is 10 and this is 20, then the area of this piece here is going to equal 10 units. Actually, I'll just exclude the units for now and I'll add them in later. So it's going to be 10 times 20, which is equal to 200. And then this rectangle, this is 10 and this is 5. So the area here is going to equal 10 times 5, which is equal to 50. And then let me use a different color. So this rectangle has dimensions 3 by 20. So the area here is going to equal 3 times 20, which is equal to 60. And then that last piece, the dimensions are 3 by 5. So the area, it's a smaller piece, so it's going to be 3 times 5, which is equal to 15. Now, if we did this correctly, if I add up all of these, so if I add up 200 plus 60 plus 50 plus 15, it should give us the same 325 value that we got earlier. So this is the second way we could do this. So let's add up. Ooh, that is not pretty. Okay, so the area is equal to 200. And all of these have units squared since we multiplied them. So units squared, units squared. Okay, so we have 200 plus 50 plus 60 plus 15. And let's see, 200 plus 50 is 250 plus 60 is 310. And then 310 plus 15 is equal to 325 units squared. Oh, look, that matches up. So this value and this value are the same, which tells us that we probably found the area correctly.